Hello, let's do LeetCode hard question 76 today. This is a classic question for sliding window. The question is asking you if you are given two strings, one is longer called S, another is shorter called T. What is the shortest substring inside the longer string S that can contains all the letters have in smaller string T? The general idea is very simple. You have a left pointer and a right pointer, and you move them in a way that it can explore all the possible substring, and it also find the minimum. So the general idea is you move the right pointer towards the right, and you move the left pointer towards the right. So when you actually implement it, the question is in what condition you should move the right and in what condition you should move the left, so that is guaranteed to find the minimum. I already draw a board here, so those yellow dots are the characters in the S. And in the beginning, because you want to cover all possible subarray, you start with 0 and you move the right pointer towards the right. You can think of this as two stages. The first stage, you want to find at least one valid window. So you keep moving the right pointer until at some point that you have a way to check all the visited subarray together at least cover all the letters in your target. But this doesn't mean it is minimum. This just guarantee it covers. And the next step is to optimize it. The next step is to move the left side to optimize. For example, it moved to here and still able to cover it, and it cannot move any further. So that is a clear condition where to stop the left pointer moving towards the right. And now the next step is tricky. How do you move the right pointer further so that you are guaranteed to still only find a better window? That is implemented by having a for loop, which basically means the right pointer will move no matter what. And whenever it moves one step, you will pause and come back to check again if this new incoming character can allow your left pointer to move more. And every time the right pointer move one step, the left pointer check and to move as much as it can. Because you don't really know which letter is blocking the left pointer is moving. So, and because another possible way, if you just started designing this solution, you may think, okay, this when the first time you find a minimum window, for example, is here, you could design the algorithm to give up the first necessary letter, give up until the left pointer meet the second necessary letter, then ask the right pointer to move until it get the left the letter the left pointer give up. But that will limit the right pointer to find all the possible smallest subarray. So what we do instead is every time when you move the right one, you keep a check to let the left pointer shrink. I think that's all. So the right pointer basically have its responsibility to move no matter what, to explore all the possible subarray. And the responsibility of the left pointer is to keep shrinking until the current subarray become the minimum version of itself. That's all. And whenever they find a minimum window, they will never give up any letters unless a new letter coming in that allow them to give up some letters that still will leave the window to be valid. Okay, sorry, my explanation not the best, but that's the best I can do. So we need two loops. One is to move the right pointer no matter what, and the second loop is to move the left pointer for the minimum, to find the shortest, as long as the window is still valid. So that's a general idea. And another trick of this solution is, how do you check if it is still valid? You can just use a dictionary to check if all the letters meet the account. That is correct, but it's not the fastest, because every time you need to go through all of them. A quick way is to keep another variable just to check the count of total letters that you need, because this whole process you will only need to count the valid, whether you entered the valid window once, you will never need to count it twice. So this is all the letters you will need with the count of each letter, and this is also a default dictionary, so it's okay if you do calculation on a letter that didn't exist on it before. Then in the end, we want to find the best left and the best right. Best. To store the return value, and you also need left and right for the process. So the right one will forcefully go through all the possible place. Sorry, I left a missing value, which is in the beginning you will need all letters in the T, and this value will only decrease, it will never increase, because you only need to enter a valid window once, and you will never exit that valid window. Oh, sorry. This is just a quick way, and you also want to do one, because when you do slicing, you want the left and the right. You don't want the right to be the exact index. You always want it to be the index plus 1, because in Python it doesn't count that one. That's why we start with 1. So whenever we use a right pointer to read a new character, we want to check if it is useful to reduce the missing count. So we minus it only if this new character is needed, which means the count of this character in our need dictionary has a positive value because it's counted from T. And then we want to update this counter. And this is where the counter as a default dictionary comes handy, because you can manage a character that doesn't matter for T, and it won't hurt anything, because later we want to check them. We just never care about them anyway. So after you get a new letter, now every time you get a new letter, you want to check if this is already a valid window. So if not missing anything, or if the total count is 0, which is equals to not missing anything, because missing will be 0 and not missing is not missing, you get all the letters you need, then you will want to start shrinking. And when you're shrinking, you want to shrink as much as you can, as long as the window is valid. So the window is valid. One is the very basic condition, the left have to have to be smaller than the right, and another is you need to keep all the necessary letters, which means the need of this character must be smaller than 0, because in the beginning we need a positive value, and when we met them we deduct from it. Yes, and as long as it stays negative, that means we have redundancy for this particular character. Well, that is true, then we can let go that specific letter. And we can also move the left pointer. And you can keep doing this until one of them not true anymore. After this left and right pointer should point directly to the boundary of the current minimum window. And now you can check if the current window is smaller than our best version. Then we want to update them. And you also need to pay attention, because in the beginning they are 0, 0. So the first time the right pointer move, you want to update them immediately, and that needs to be guaranteed. So if you don't have a right best yet, you should also update it. So this is implemented here. So that's all. You can return the best left and the best right. Oh, sorry. So when you shrink the left, of course you should check the letter that's pointed by the left pointer, which is pointed by the left. The C is the one pointed by the right pointer. Oh. So that's all.